what are the types of graphics? Computer graphics can be divided in many perspectives. So in one perspective, in terms of pixel, computer graphics can be divided into two parts: raster graphics and vector graphics. What is a raster graphics? Where each pixel is separately defined, as in digital photograph. And what is a vector graphics? Where mathematical formulas are used to draw lines and shapes, which are then interpreted as the viewer sent to produce the graphic. So if it's fine if you don't understand the definition, we'll see some examples very soon. So just remember these two things. In raster graphics, we use pixel which are separately defined. That means each pixel has a separate value. So if I think, let's assume this is a box. So here, if I draw something, if I draw a line, okay, so this is the line. So here, let's assume this is a pixel, this is the pixel, this is the pixel. So these are pixels. So each pixel will be separately defined, separately stored in case of raster graphics. And in case of vector graphics, we will not be concerned with the pixel values. We'll actually concerned about the equation or mathematical formulas. And now one point you have to remember, vector graphics can be magnified infinitely without loss of quality, while pixel based graphics cannot. Okay, so this is the main point difference between them. Raster graphics cannot be magnified infinitely. There is a, if you magnify your picture, you will see it will get blurred. So this is the difference. Now, more on the example. So here, as you can see, here we have a picture, and if I zoom this small part of this picture, okay, if this picture is a vector, even if I zoom this small part, we can see clearly what's written, that is ice. But if this is a bitmap image, that means a raster image where each pixel is defined separately. You know, if I zoom this, if I zoom, you see the ice, you cannot read actually. So that means if you zoom the raster image, okay, it actually harms the quality. So that is the difference. Now next, again, you see the picture of the burger. Okay, so here we have this vector image burger and we have this bitmap image burger. So if you zoom the burger image in 125% in the vector image, you can still clearly see the part of the burger with the and with the picture, and even in the 350% zoom, you can clearly see this lettuce. Okay, but if you actually take a bitmap image and if you zoom it, okay, you see the picture actually gets blurry. This picture is, there's no way to understand what this actually means. So this is another example. Now, so we can agree that vector image maintains the quality, doesn't matter how much zoom you want to do it. And bitmap image, actually, if you zoom it, it gets blurred. What is the main reason? The main reason is vector image has generated using mathematical formulas, and bitmap image are generated using pixels. So if you zoom pixels, it gets blurry. So that is what we need to learn. That's, and you remember. Next one. So we'll now study in details what is a raster graphics. Now, if I go one by one, so raster graphics is actually called bitmap graphics, are digital images that are composed of tiny rectangular pixels. So again, we go back to the definition, what is pixel, and you remember the pixels are the smallest element of an image or picture elements that are arranged in a grid or raster. So you see the pixels are arranged in a grid or raster or X and Y coordinates. So if you think of a graph paper, if you remember in a graph paper, what we have small boxes, like, so small boxes of, what should I say? In the graph, we have like lines of X and Y, and in those lines, we have small boxes of rectangular. So we can define those boxes as a pixel. Now, it is also referred to as bitmap image since it has information that is mapped directly to the display grid. Now, let's see one example. The size of the raster image depends on the size of the image. So what does this mean? That if an image with 172 resolution will contain 921 into 600 pixels. So that means that if the more pixels you have in your image, the more space it will take. So if you remember previously, whenever the cameras were actually around 2006, 2005, the cameras were actually around 3 VGA cameras. The mobile, I'm talking about the mobile cameras. They were VGA cameras, or some of the cameras, they were 3 megapixel. And when you used to take pictures with those cameras, the image size would be around 500 kilobyte, 700 kilobyte, or maximum, 1 megabyte. But nowadays, with the high resolution cameras that we have, if you take a picture, what happens that especially with the DSLR, you will see that one picture actually contains around 40 megabyte, 50 megabyte, 30 megabyte, depends on the resolution of the camera. So from now we understand that why the resolution actually, the size of the image is so much more, because the better the image, the better resolution you have, okay, the more pixel you need to store. So here, if your image resolution is 1280 into 720, that means if you multiply these two using calculator, you will get 921, sorry, 9,21,600 pixels. If you multiply a full HD picture, that is 9020 into 1080 resolution, it will have 2,073,000 pixel. So the more pixel you have, the better quality you get, and the more space you need. Now, in computer graphics, a raster graphics image is a dot matrix data structure. This is the book's definition. I just have to show it to you, but you don't have to remember it. The raster graphics image is a dot matrix data structure representing a generally rectangular grid of pixels or points of color, viewable via monitor, paper, or other display medium. Raster images are stored in image files with varying formats. So we know that there is a JPEG, there is PNG image, and so on. So this is the bookish definition of raster graphics. Let me repeat one more time. What is raster graphics? A dot matrix data structure. First part, a dot matrix data structure represents rectangular grid of pixels or points of color. Third part, viewable via monitor, paper, or other display medium. So there are 3 parts of this definition. First part, raster graphics image is a dot matrix data structure. Second part, it is represented as a grid of pixel, point, or color. Third part, it is viewable via monitor, paper, or other display medium. So this is called raster graphics. And there are different formats, JPEG, PNG, and so on. Next definition, a raster is technically characterized by the width and height of the image in pixels. So basically, if the image height is, let's assume that this is the image. So if you have like 100, 200 pixels in this axis and 500 pixels in this axis, so the raster image will be defined as 200 into 500, okay, or 500 into 200, depending on the X and Y. Normally we actually represent the X first, then Y. So if I take this picture, okay, so this will be X, that means X will be 200, and this will be Y, Y will be 500. So now we will see that how we actually represent the data in the raster image. So here, this is the one last example. You see, this is a small smiley face. And if you actually zoom the smiley face, you will see that there are small circular grids. So basically, a smiley face is actually consists of small circular grids. And here, as you can see, we have taken 3 grids, first, second, third. You see this 3 grid, if we mix those 3, so in the first grid, you see this is white. So the value of R, 93%, value of G is 93%, value of B is 93%. Now, if you don't remember what is this means, R 93%, G 93%, B 93%, basically whenever we're using the RGB color scheme, so every color R has a value from 0 to 255. The G has a value of 0 to 255, and B has a value of 0 to 255. So each of these color grid has a value of from 0 to 255. So what does 0 means and what does 255 means? These are basically the level of intensity. Okay, so from light to dark. So using those intensity, you can actually draw a picture. So if all of them actually are in the 100% intensity, that means to 100%, 100%, you will get white. You see the second one, if we zoom the second one, you see here this is actually dark, so that means R 35%, G 35%, B 16%. So the less value you have, the darker it gets. And here the yellow, in case of yellow, you see if we mix R and G, you get yellow, and B is 0%. That means you don't need B for the yellow color. So as you have seen that using this RGB, we can actually generate 60 million colors. And if you understand how one pixel is represented, whenever we are actually seeing a picture in the screen, for example, look at this picture. So here in this small part, we have 3 pixels. For the first pixel, it's almost white. So that means R is 93%, G is 93%, blue is 93%, because it's not totally white. Second pixel, you see, is little bit dark. So R is little bit small, 35%, G is 35%, and B is 16%. And for the blue one, we have R 95%, G 90%, and B equals to 0%. So what we understand here, that every time you actually see an image or a video, okay, you are actually seeing lot of these pixel values in this screen. And the more pixels you have, the better picture you have, okay? So this is actually the raster graphics. Now, what is a vector graphics? Rather than a grid of pixels, a vector graphic consists of shapes, curves, lines, and text. And vector graphics are based on vectors, okay, also called paths, which lead through locations called control points. Now, for the vector graphics, you have to remember only 2 things. First of all, vector graphics consist of shape, curves, line, etc. Okay, that means vector graphics is not dependent on pixel, okay? And secondly, that in the vector graphics, okay, it leads through location called control points or control nodes. So what is a control point and control node? So in the next picture, let's see the example. So you see here, you can draw an S using vector graphics. To draw an S, what you will do, you will actually first fix some points like this. You see the points here? First, you will actually select these points, and after actually finding out these points, you will just use the mathematical formulas to draw lines between these points. So from this point to this point, you will draw one line. From this point to this point, you will draw one line. Those can be straight line, those can be curves, those can be points, those can be shapes or polygons. So first of all, in the vector graphics, we use geometric primitives such as points, lines, curves. And what else we do? We actually lead through location called control points. So if you want to draw a vector graphics, what is the first step? The first step is to find out these control points, these points you see in the screen. So using mathematical formula, you can actually find these control points. So if I ask you, draw a A. So let's assume I want to draw an A. So for A first, so we know the normal shape of A is like this. So using mathematical formula, whenever we want to draw a vector graphics, this is a raster graphics, okay? So whenever we want to draw a vector graphics, first we'll actually find out the control points. So let's see, this is one control point, okay? This is another control point. This is one control point. This is another control point, and this is one control point. So after defining this 5 control point, I will just connect this control points or the paths, and here is another one, and we'll get an A. So this is how actually vector graphics work. So here, as you can see, the vector graphics, if this is same A, first one is drawn using vector graphics and second one is drawn using raster graphics. If you zoom into the vector graphics, it's smooth, okay, it's full, it's clear. And if you zoom onto the raster graphics, you can see small boxes, just like the boxes in the graph paper. Same goes for, you see, this is in this raster and this is in the vector. And even we can not only draw alphabets or lines, we can actually even, we can draw this picture using the vector graphics. So this was the one definition of graphics, and there is another definition of graphics, types of graphics. I will explain this type of graphics, then I will give you a 10-minute break for the namaz, okay? So first of all, what is the another type of graphics? Another type of graphics is divided into 2 parts. Interactive graphics, that you can actually interact with the graphics, or you have some control over the picture. You can make can make any change in the picture, produced image. So that is called interactive graphics. And what is interactive graphics? Involves a two-way communication between computer and the user. Here, the observer is given some control over the image by providing him or her with an input device. For the example, the video game controller of the ping pong game. So if you remember, in the ping pong game, you can actually move the, the bat to strike the ball. Okay, or we can think about this helps him to signal the request to the computer. And if we talk about any game that you play, for example, the Candy Crush, okay, this is also an interactive graphics. You can actually interact with the graphics that you see in the screen. If you actually press it, okay, some events occur, okay, it either bursts or you get some points, okay. So this is called interactive graphics. And the user, the picture changing instantaneously in response to the command. So whenever you, in the Candy Crush game, whenever you actually select a candy, either you get some point or something happens. I don't know, I didn't play the game, but you get the idea, right? And each one generating the graphical response from the computer. That means here the computer program helps. That if you actually select the red candy, it might happen that it will burst like a bomb. If you select the green candy, you might get some bonus point. So all of these are actually done using the help of computer program. And also simulation software helps to train the pilots of the airplanes. So this is called interactive graphics, where you can actually communicate with the graphics or the image or the video that you see. What is non-interactive graphics? Just like screensavers, some pictures where you can actually see it, you can zoom it, but you can actually change it. Okay, you can actually modify the picture using another software, but in the most of the cases, the non-interactive graphics, you cannot actually communicate. So think of pictures, animations that you can actually modify, or think of animation, picture, videos that you cannot modify. Then you will get the definition. So if you can actually interact with the animation, pictures, this is interactive. If you can't, that is non-interactive. Just think about video. Whenever you're playing a video, you can either just pause it or you can actually play it, but you cannot actually interact with the video. Okay, so these are the two types of graphics. Now, in passive computer graphics, image is merely the product of static stored program. We'll see more how image is actually produced. You will find it very interesting. Now, these are some of the display devices that actually we use for displaying the graphics. Okay, that means we to show output in the monitor, raster scan display, random scan, direct view storage tube, flat panel display, 3D view display. Then we also use virtual reality. So if you're familiar with virtual reality, you have seen that you wear something, a box in your eye, it's almost like a glass. Okay, then you can actually communicate with the environments. If you move right, you see the things on the right. If you move left, you see things on the left. And raster scan, random scan, these are our normal monitor, the three flat panel display, LCD, LED, OLED. You have heard of the names like CRT monitor, LCD monitor, LED monitor. So these are different types of display. So this brings us to our end of lecture 1. Okay, so now we'll go to the lecture 2.